Welcome back to the Sani podcast, the podcast that celebrates African scientists. My name is Alex Nyako. I'm a senior research specialist at Avery Dennison.
And I am Talasi Wiafrikwache, a PhD student in microbiology at the University of Maine.
So today we are very excited to have with us Dr. Mesfin Tsige. Dr. Tsige is originally from Ethiopia and is currently a professor at the University of Akron at the School of Polymer Science and Polymer Engineering. So Dr. Tsige, thank you so much for joining us. We are very excited that you have accepted our invitation to have our discussion this afternoon. And we're glad you made time to be with us to talk about your research, talk about your past experiences, and talk about your passions as well. So once again, thank you so much for joining us on Sani.
Thank you very much for inviting me. Alex, I know you for quite some time when you were a graduate student around here, and it's a pleasure to talk to you on this forum.
Good to see you again.
Good to see you.
It's great to meet you as well.
Yes, exactly. Nice meeting you both.
So I want to kickstart our discussion today. We want to talk about, first of all, how did your past experiences has shaped your career direction? We're thinking much more in terms of your experiences from Ethiopia and how you transitioned to graduate school and then eventually to your current role. How did all of that experience influence your career direction and the field that you decided to pursue?
Well, pretty much, everything we do in research, it gets back to your main background in a sense that what you are comfortable with. So in my case, growing up, I was really good in math, and that allowed me to get into physics because physics combines math plus understanding the physical laws. So that's where the numbers actually make sense. Come up with numbers and physics tells you that it means something in what we actually do on a daily basis. And my background in physics allowed me every time to understand what's going on in nature, why things work. And that curiosity led me to come to graduate school. Obviously, when I came to graduate school, my interest was to continue doing in physics. And that's what I have done. I came to Case Western Reserve University in Cleveland, Ohio, in the physics department, and I joined the soft condensed matter physics.
Okay.
So soft condensed matter physics deals with, the kind of research work we do in polymers as well. Right. Someone may think that, well, polymer is not, as a physicist, why do you work in polymers? Yeah, they think polymer, more biologist or chemistry, yeah?
Right.
But there is always that fundamental question you ask, how do they work? And that always requires some understanding on the physics side. So when we come to polymers, we have polymer physics, polymer chemistry. And early in my graduate school, around, I think at the end of my second year, I was introduced to polymers. Okay. Early in my PhD, I started working on liquid crystals.
Oh, that's interesting.
Yes, this was NASA was interested to find out how liquid crystals, which are really different from polymers, behave in a microgravity environment. That means in the absence of gravity, because liquid crystals are used for liquid crystal displays, and how things will change once you go to space. There is no gravity. That's how I got started trying to understand the physics of molecules, macromolecules. Then from liquid crystals, I went to polymers. And on the polymer side, I was involved in this fundamental problem of looking at how things diffuse into polymers, gases. Let's say we have these plastic bags that we use for packaging and so on. We use plastic things for packaging meat, different kind of application. What is behind is you don't want a certain type of gases to diffuse into those kind of materials,
Right.
And that requires some kind of understanding on the physics side. So everything I have been doing since my graduate school is directly connected to my physics background, and especially in soft condensed matter physics. And the kind of research work that I'm doing today is also in that same direction. Every now and then we ask, how does things work? That gets back to the fundamental laws of physics.
Right.
And pretty much that's my short answer to your question, Alex.
That was a fascinating story of how your interest in math eventually has led you to polymer science, and that brings me into a question about. So, what do you think? What other field do you think you might have ended up in if you hadn't gone into physics? Looking at how you were good in mathematics growing up.
I would think. I think I would have gone to electrical engineering.
Oh,
yeah,
okay.
that would have been electrical engineering and physics pretty much go side by side.
Yes,
right.
yeah.
There are a lot of overlap. I think if I have gone to a different field, which I have considered, obviously, when I made the choices, electrical engineering was in my list. And that's for a reason. When you go and look at what many electrical engineers do, pretty much they are applying the laws of physics on a daily basis.
Right.
So I could see math, physics combined in applied sense in electrical engineering. I think electrical engineering would have been my other choice if I was not a physicist.
Oh, yeah.
You're glad you came to the polymer side.
Yeah, now knowing where I am, because I don't know where I would have been if I were an electrical engineer.
Right.
But right now, I'm pretty happy that I chose physics and where I am right now.
So, Mesfin, I was also wondering, how do you think your experiences back in Ethiopia helped to shape that love for maths, which eventually developed gradually into building up a career in physics and then eventually into polymer science?
Yeah, so I think in everything you do, confidence is very important. And building that confidence early on really decides where you are going in the future. So in my case, when I was in elementary school, middle school, the kind of support I got from my teachers, pretty much implying that I have a good future. My skills, especially math skills, were great. Gave me the confidence to focus and take advantage of that skill sets I had. And every time when I was looking at my future, I said, I'm going in the sciences. I never saw me going, let's say, in history or politics. I just defined that my direction should be in STEM, science-related fields. And of course, how I became a physicist, that's a long story, because one, nobody told me the difference between maybe physics and chemistry early on in my childhood. But as you go along high school, you start to understand the difference. But for a science-oriented student, both are very attractive. Then when you go to college, you somehow realize that chemistry takes more time, especially in the laboratory, and you have to remember some organic molecules name, very long. And I was not that kind of person. Memorizing, I don't. You have to memorize long names. Then that somehow started to discourage me, even if I was, I think, I was happy with the chemistry as well. That kind of, early your exposure, the kind of community support that you get helps you to think what are your futures. And as you go in that path, of course, you discover some new things that you have never anticipated. You never thought that you would be going in that direction. Let's say if you had asked me when I was undergraduate student in Ethiopia about polymers, I had no clue.
Right.
Okay. I never told I wouldn't have said anything. I would have said what's said. But the fact that I said earlier in your previous question, as we go along, my passion in science, and mostly in physics, led me to where I am today. And that has got to do with the kind of help, appreciation, and encouragement I got early on in my career as a child.
Right.
That was really critical. Building my confidence early on, and pretty much be ready to not to fail at all. Every time I see something is challenging, I say, I'll take a couple of weeks to get it. Actually, that's how I got involved with. You may be asking me later on, how I got into simulation, I'm assuming.
Yes.
But I'll tell you later on that when I got to simulation, I got the same kind of difficulties early on, coming with no programming background.
Yes. Yeah, it's very important that we build confidence in our youth,
Yes.
just so that they can also face these challenges. Because I agree with you totally that's the one skill that helps you to decide that you'd want to face a challenge head on. And you talked a little bit about it just at the end of your statement. And so we did a little background on your specific research and saw that you work on simulation of molecules at surfaces and interfaces. So we have a range of audiences here, and would like you to kind of explain what your research entails in layman terms, in terms of the simulation of molecules.
Okay, yeah. But then I think maybe I could give a little bit background how I got into simulation.
Okay.
So when I came for my PhD in the US, my initial plan was to do paper and pencil, which means sit down and develop models and solve problems. So at the end of my first year, we came up with a model, and that required a numerical calculation. That means we have to use computers to solve it. And then when my advisor said, oh, go ahead and solve it numerically, I said, I have never written any programming language. I've never taken any programming course. He just simply said, you are a physicist. I'll give you 2 weeks time just to expose to yourself somehow to understand the basics of programming that unit. That's how I got involved in doing simulation. I got started. Initially, it was frustrating, to learn a new language that you didn't know. But as I started to discover more, I see the huge potential going in that direction. So I took that as another route in my career. In addition to the paper and pencil that I wanted to do, I said simulation would be the other way to go. And as I keep on expanding that simulation, I started this more than 20 years ago doing simulation. Actually, about that was in the 1997. That's the time, quite some time back. And during that time, simulation was at the early stage.
Right.
So we had a lot of potential in terms of influencing what comes after that. And that involvement helped me to expand the power of simulation in the polymer field. Polymers were very challenging where I'm working right now. And when we come to polymers, it gets into that basic question you said in a layman way. What do we mean by, well, when we think of surface and interfaces, I think the one thing I could bring to you guys is what we learned in high school early on about friction. You see, when you talk about friction, you bring 2 materials together and how easy you can move one on top of the other is the kind of surface problem that we always encounter in our daily life. That's at a macroscopic scale, at a larger scale. And of course, what we wanted to understand is how that friction actually happens. That friction in today's nanotechnology application, we require putting 2 or many materials on top of each other. And the nanotechnology at the nano actually implies it is like, if you were magnify these nanomaterials 1,000 billion times. We can see them, okay? But we don't see. Now we wanted to understand what happens when we bring these small things that we couldn't see on top of each other. Everything that we can think of, either their electrical properties, thermal or mechanical, depends on what happens at the joint when they come together.
Okay.
And that property is what we call the interface, at the interface between the two.
Oh.
Yes, and that requires a molecular level understanding. Molecular level understanding means looking down in that 1,000 billions smaller things. And the only way we could access that is either using sophisticated experimental methods like Alex has used in his graduate school, the some frequency generation on one side, and on the other side is computer simulation. And this computer simulation, the kind of simulation that we do, in our case, we call it molecular dynamic simulation. It looks at atom by atom. And that allows us to understand what's happening at that interface. And so in our case, we are more on the fundamental side, but you can directly connect it to the macroscopic world that we are actually observing friction. That friction is what's translated in all of this application, how they pack at the interface. I'm not sure if I fully answer your question, but I think I can expand on that one if needed.
Yeah, I think it was very clear.
Yeah, I think it was clear. At least talking about the friction was a good basis for us to understand fully.
Yes, at a larger scale, I think friction everyone can understand. You know,
Yes.
on a smooth surface, you can walk, you can drive your car very easy. When the road becomes rough, it becomes harder.
Right.
The same thing happens at the nanoscale that we don't see.
Yeah. Yep.
Yeah. So Mesfin, what are some of the memorable highlights and lowlights in your research so far? If we were to share that with an up-and-coming physicist or simulation scientist, either from Ethiopia or from the African continent as a whole, or even here in the US, what are some of the memorable highlights and lowlights in your research?
Oh, there are many. So let me focus on the few ones that I could comfortably list. Well, I think in terms of the memorable ones, I would say when I started my independent research as an assistant professor, tenure track, knowing that you have just started your own independent research work, getting my first paper published with my graduate student was memorable. That was really saying that, yes, I'm setting up the stage, now I am leading.
Right.
That was really memorable. After that, it becomes, routine. You are doing it more and more often.
Okay.
But the first time when it happens, it is really great because you are questioning yourself, is it going to work out? Is the community going to accept the paper in these, internationally recognized journals? And when it happens, it works. Of course, when it happens again, you become happy. After that, as I said, it becomes routine.
Right.
Yep.
On the other side, especially as a researcher, your work has to be funded. So you have to write grants. And on that side too, you wonder whether you are going to get that first funding to get started. And as you guys know, getting funding, the probability is very low, usually 20 or 10% or less. It's a fierce competition. And that's always, a challenge whenever we think about our research work. So when I got my first grant, saying that, you can work for the next 3 years, support a graduate student, that was excellent.
Nice.
Of course, on the other side, on the downside, they are directly related to this one. When your proposal gets declined, you go down.
Yeah.
And that pretty much happens many times, given that the chance is very low, there is a 4 to 5 chance that your grant keeps on getting declined.
Right.
So you have to get prepared. The first
Yeah.
couple of times it happens, it takes you down. And of course, you submit papers with your graduate students. When the reviews are not good, it takes you down. So it's always, you are, as an academician, there are always this up and down moments that you go through. Later on, you get used to it. But at the beginning of your academic career, it's very important that you quickly adjust. That means you got to expect that it's not always easy.
Easy. Yeah.
Yes, to go through. You have to understand, that's the mechanism, how things work. But get ready to improve yourself. Understand from, the suggestion that you got, and also how to improve going forward.
Right.
Otherwise, if you just simply say, oh, I don't think this thing is going to work out, I don't think it's going out for work for me, then you are doomed. Always, you have to get ready to learn. If you have done mistakes, you correct them. Or if you think that you need to collaborate with others to get things going, you better do that quickly. Time really flies fast. So in my case, I think most of the things that happened early in my career are both, as you put it, memorable highlights and also lowlights in my academic career.
Okay.
Okay. Thank you for sharing that. It's one of the, I guess it's part of the what everyone has to go through once you go into academia. So at least our listeners who will be interested in going to academia would know that these are some of the things that they should be looking out for, and they're kind of expecting, and not allow it to completely derail their passion for being in academia. So we wanted to know a little bit more. So you coordinate the research experience for undergraduates, and we wanted you to tell us more about your passion for mentoring undergraduates and introducing them into research. Just giving us a little bit more about that passion that you have.
I'm very happy. I'm glad that you raised that question. Yeah, because when we think about graduate students, their undergraduate experience is very, very critical.
Yes.
If they are exposed in undergraduate research, mostly you find them being very successful when they come to graduate school. They know what they wanted to do. They have that background, and they have already identified what kind of research work they wanted to work on. So in our case, the reason we get involved into our undergraduate students is for two purposes. One, the school where I'm at right now is a graduate program so far. And we need a pipeline for our graduate program. And there are very small number of universities offering undergraduate programs in polymers. So this the research experience for undergraduate summer program that we run, I have been coordinating this for over 8 years now. Allows us to bring a dozen of students every year and export them to polymers. And that gives us a chance to reach out to many students, not only those students who participate in the summer, actually students, more than hundreds of students who apply to our program for that summer research.
Wow.
Because it clicks in their mind, there is a polymer science at the University of Akron. So when later on they think about graduate school, they would think about our program. And second, if you want to make changes in the life of a student, either you start in elementary school or you start early in college when they come to undergraduate. The college side is for those who want to go to research. And undergraduate students, most of them are really very passionate about doing research. They are very happy. They want to show that they are capable of doing something beyond homework assignments. Homework assignments, they are well targeted. Sometimes you can look at the end of the book for answer,
right.
Make sure that you have done it right. Yeah. But research is totally different. If we know the answer, then obviously we don't do research. Yeah? Research is completely unknown. So you want to bring them in that open thing, which you don't have a complete answer immediately. That rarely happens in research. So the exposure, and when they find something, the kind of happiness that you see in their face develops a passion in you. And that's why we want to make an impact early in their career. In some cases, you are also helping them if they really want to go to graduate school. I think looking at the experience in the last 8 years with these undergraduate students participated in our summer program, many said, oh, now I see that I can be a graduate student. Yeah, because they have worked with graduate students during their stay. And rarely a few would say, I see that I don't want to go to graduate school. I think this gave me the chance to see what graduate life is going to look like. I don't think I'll continue like that. So this gives them the opportunity, to make the right decision.
Yes.
And many of them have been very thankful. And that's why I've been really passionate about getting undergraduate students in research and obviously helping them flourish going forward in their career.
That's wonderful. And I personally attest to it, spending time in the department, the passion that you take in championing this effort. And I know that through your effort, you've really impacted lots of students who have gone through the program and who have transitioned either in academia or even into industry, have really been impacted by the work that you've done and the work they are still doing. So Mesfin, we'd like to round our discussion off by asking what advice do you have for up-and-coming scientists from the African continent who are seeking to advance their career in science and who are developing a deep desire to grow in their scientific knowledge?
So I think right now, unlike my time, now the world is really small. You don't have to come to Western countries to get information, the kind of research work that's being done anywhere in the world. So my advice is first check out, find out what's being done in the kind of area that you want to work on. Be informed, especially if you are coming to graduate school in Western countries. You are working with students coming from all over the world. Students from Asia and a few other countries. There is a huge difference in terms of preparation. And that difference usually comes with how we prepare in our schools. I think it's obvious that there is that stereotype that we have to always get ready, in a sense that when you say I'm from Africa, the way students from other countries look at you is as if you are not prepared. So you have to prove that quickly. And that's why that requires some kind of, you have to prepare yourself. And when somebody points out that to you, or you sense these days, they don't point out to you directly, but somehow you feel it, When that happens, don't get down. Prove them wrong. Work hard. There is a good chance that, yes, you may not have been exposed to those kind of things that you are learning in Western countries. But everything is possible with hard work. Yes. Just put yourself, and in a few weeks, you should be able to bring yourself to where the others are. And once you build your confidence early on, the next year and the year after becomes very easy to overcome. The initial few weeks or several months are where you are tested. You see, some of them are skeptic about what you can do. But once you prove that in the first few weeks, then you are set. And obviously, as I think, as I said early on at the beginning, confidence. Confidence is key. Believe in yourself. Don't get down. Don't get disappointed. But always, look straight forward. Don't look down. And you should back up that with hard work. Right. Okay, if you don't work hard and if you just sit down, nothing actually counts.
Yeah, that's true.
And that definitely helps you when you look at where we are in the US. It's called the land of opportunities. As we know, if you work hard, there is a lot of opportunity. That's why we all, including you and me, we are successful in this country. And for those who are planning to come to the US or to Western countries, they have future, and that future is built on confidence and preparation. I think that's pretty much what I would say, answering your question briefly.
Thank you so much. So it looks like the theme really running through our discussion is the confidence.
Yeah.
Confidence from different aspects and taking that confidence along with you in all that you're doing.
True. Yeah. Absolutely true.
So I just want to thank you so much, Mesfin, for joining us in our conversation, for agreeing to join us on Sani, really emphasizing the role that African scientists are playing in the scientific community and celebrating African scientists. And we are very excited to have you on our platform today. We are very glad that you've joined us, and you were so enthusiastic when we reached out to you to join us to have our discussion, to show what you are doing, show your passion, and also to encourage young up-and-coming budding scientists from the continent.
Oh, really? Thank you so much. By the way, to your audience as well, if they are interested to learn more about my research work, they can go to the University of Akron, School of Polymer Science and Polymer Engineering. And if they want to apply to graduate program, they can also contact me by email. We have contact to a couple of schools in Ghana, actually. I'm not sure, Alex, if you are aware of it. But we are also trying to expand to other parts of Africa.
Okay.
If any of your audience if they plan of having that connection, I'll be happy. They can probably find my name, email me, and we can establish that kind of connection. And it was really a great pleasure talking to you guys. I didn't realize how time runs fast. We are already over half an hour. Yeah, I understand. Yes. Yeah, it was really nice talking to you both.
Yeah.
Yeah, thank you.
Yes, and thank you to our viewers and audience for joining us, and listeners for joining us today. So as usual, you can find us on Facebook as Sani, on Instagram at Sani Podcast, and on YouTube as Sani Podcast. Don't forget to like, share, and subscribe. And for our viewers on Facebook, Instagram, and YouTube, send us your comments on today's episode, and we'll see you at our next session. Thank you.
Thank you. Bye.
Thank you, Bye. Bye.